Welcome back to the 8-Bit Guy. In this long-awaited episode, we're going to dive into the history and architecture of the TI-99 4A. Of all the computers I've covered, this machine has to be the most bizarre architecture. It's the first 16-bit home computer appearing on the market in 1979, just 2 years after the birth of the home computer market that started with the 8-bit machines like the Commodore PET, Apple II, and TRS-80. One of the reasons I put this documentary off for so long is that I had to first wrap my head around how this crazy machine works before I could even begin to explain it to the rest of the world. There's a lot of really odd things about this computer. Let's start by looking at the name itself, TI-99 4A. It seems like an unnecessarily long and complicated name, much harder to remember than something like Apple II or Commodore PET. And I do feel this name probably didn't do the system any favors in the marketplace. That being said, the name makes sense when you look at how Texas Instruments named their products. For example, the TI-30, one of their early calculators, or the TI-81 graphing calculator, which was common to see in math classes back when I was in school. And so, TI obviously stands for Texas Instruments. 99 is the product series, and 4 is the model number. Originally, there was going to be 3 different models, the 2, the 4, and the 8. The 2 is going to be a smaller, cheaper model, and the 8 was going to be a more powerful model. However, while prototypes of these were made, the 2 and the 8 never went into production. So in this episode, we're going to be looking at the original Model 4, the later 4A, and then the second generation of the 4A. Okay, so let's have an overview of the original TI-99 4. So obviously you'll notice it has a chiclet keyboard. And it's not great, but it's not terrible to type on either. I guess everything's all relative. So one advantage this has is you could put these special overlays over the keys so that you could have special instructions for certain software. But one bizarre thing about this keyboard is the extra space over here. And it is actually wired exactly to the same wires as the main space bar. I'm trying to figure out exactly what the purpose of that would have been. I've Googled it. I haven't found a lot of answers. Some people said that it was kind of a carryover from older style typewriters having an extra space key, but I've looked over Google Images and looked at hundreds of pictures of old typewriters, and I've yet to find a typewriter that had a space key like this over here. So actually, I really got to be honest, I have no idea why there's an extra space key there, but anyway, so that's the keyboard. Now, if you weren't necessarily familiar with TI, you might look at this port on the side and say, well, that's probably a joystick port. And then you might look here at the back and say, oh, well, look, there's the other joystick port for 2 joysticks. But no, actually, that's not the case. So while this is the same physical connector that you would see with an Atari or a Commodore joystick, it's actually not the same pinout. In fact, this one joystick connector operates 2 joysticks. I'll show you how that works. Both joysticks are connected together and plug into the single port. And you might be thinking that there aren't enough pins for 2 joysticks, but it's pretty clever actually. If you look at this diagram, you can see that all the joystick switches share the same pins, but the computer can pulse either joystick A or joystick B to see the results of any movements. It works similar to a keyboard scanning routine. Also, TI-compatible joysticks are kind of a pain to find, and I don't even own any. And there are far more of these computers in the wild than original joysticks. Fortunately, TechSelect produces this little adapter board that can expand out to take 2 Atari-style joysticks, which are much easier to find, and that's what I'll be using throughout this video. So looking at the back here, this is the standard AV port. This is more or less compatible with the same type of cable you would use on a Commodore or Atari, so that was fairly standard at the time. And then over here, we have both power and that other thing that looks like a joystick port is actually a cassette interface. Now, one interesting thing the 4 has is a headphone port right there. Then, of course, over here, we have the power switch. And over here, we have like a extra expansion port, which we'll get to later. And then, of course, the main cartridge port. And the way this works is you have your cartridge shaped like this, and you just nicely slide it right in there like so. And the cartridge is designed so that you can grab it and just pull it out. So that's the outside. Let's hook it up.
But before I do, I should also mention TI had a custom monitor for the TI-99, which was actually just a modified Zenith Chromacolor 2 television with a TV tuner removed. In fact, you can even see where the antenna originally mounted, along with some screen adjustment controls on the rear. It also had a handy carry handle on top. However, I don't have one of these handy at the moment, so I'll be using my regular Samsung television for the moment. Okay, so I have it connected to my television, and you'll see when I power it up, it goes to this colorful intro screen and waits for you to press any key. In fact, this could be one of the earliest usage of the any key prompt, which has become a running gag with computer enthusiasts. Anyway, after pressing a key, we are greeted with two more options. We can press 1 to enter TI Basic, or 2 for the equation calculator. So let's try out Basic. There's a few things I should mention right away. One is there's no lowercase characters, just uppercase. The other thing is you'll discover right away that there is no backspace key. But if you look at the keyboard, you'll see there are these arrow keys on E, S, D, and X. And so you have to press Shift and S to back up and then retype over what you messed up.
Okay, so I've said this before, but I think it's worth repeating. Yes, the keyboard on this machine is terrible by today's standards, but I think we should really look at it through the lens of someone buying it in 1979. Back then in the 70s, there really wasn't a standard for keyboards, and most people didn't know how to type anyway, and so they had no preconceived idea of what a keyboard should have been like. However, for us modern folks trying to go back and use a TI-99, it can be actually readily frustrating.
One other interesting thing is the screen color changes to green when a program is executing. You may also notice it seems a bit slow, and we'll talk more about that shortly. And the screen returns to this sort of cyan grayish background when you break back to the command prompt. Okay, now let's take a look at the equation calculator. Obviously, you can do simple math in here like 2 plus 2 equals 4, but you can also define variable names. I'm just making some stuff up here like size and circumference, and you can do some fairly complex math in here. Okay. So let's see how cartridges work. We'll take TI Invaders and just slide it in here like so. And you'll see that on power up, I now get 3 options. So even with the cartridge in place, I could still drop to basic if I wanted to, which is different from how most 8-bit systems work. But let's pick option 3, and there we go, playing TI Invaders, which is obviously a knockoff of Space Invaders.
So before I get into the details of how this crazy TI-99 architecture works, I think it's important to understand another piece of history which sort of goes a long way to explain exactly why it is the way it is.
Suffice it to say, the computer was originally planned to be an 8-bit computer, possibly using a clone of the 8080 CPU, or an off-the-shelf 6502, or TI's own TMS-9985, which was technically a 16-bit CPU internally, but was designed for an 8-bit system bus. But at some point during development, a decision was made to abandon that CPU and instead use the TMS-9900, a fully 16-bit CPU. But much of the board was already designed to accommodate an 8-bit CPU, and there wasn't time to redesign everything, so it ended up being this weird hybrid. If you look at the TMS-9900 CPU, you'll see it's a true 16-bit CPU. It's a rather large chip with 64 pins, and that's because it has 16 data lines, meaning it can read or write 2 bytes simultaneously, and it can access 64K of RAM by having 15 address lines. Now, this may seem odd at first, being all of the 8-bit CPUs I've talked about typically have 16 address lines in order to access 64K. So you might think with only 15 address lines, you would only be able to read 32K. But when you take into account that the CPU reads 2 bytes at a time, you can only point the CPU to even numbered bytes, and it's always going to read that byte and the one after it. So indeed, you only need 15 address lines for this CPU to access 64K. This is the same CPU that Texas Instruments had been using in their 990 mini computer series, and these were designed with multi-users and multitasking in mind. The CPU wasn't necessarily a great fit for a home computer. Now here's where things get strange. The CPU can only directly talk to a handful of things, including the TMS-9901 interface chip, the TMS-9918A video controller, 8K of system ROM, 8K of cartridge ROM if one was inserted, and 256 bytes of RAM. You heard that right, just 256 bytes of RAM. But the system was advertised to have 16K of RAM, so where was that? Well, this is connected to the video chip and acts primarily as video RAM for things like graphics, sprites, and text for the screen, but it can also be used to store just about anything you want, The trouble is, it requires a series of instructions to request the video chip to fetch or write a byte in this RAM, which means the CPU cannot directly execute code from this area, and accessing it in general is going to be pretty slow. Believe it or not, when you write a program in BASIC on the TI-99, your BASIC program is being stored right here in video RAM. Now, this already cripples the speed of BASIC, but it gets even weirder still. To illustrate this, imagine the CPU itself, and it's running a special language interpreter called GPL, which stands for Graphic Programming Language. By running an interpreted language, this allows it to execute code in weird places like video RAM. Then BASIC itself is actually written in GPL and thus runs on top of that. And then the program you as a user create runs on top of BASIC. So your program is being interpreted twice over. Now I figured a good way to illustrate the inefficiency of this would be to write a small program in BASIC on the Commodore PET. It's designed to find prime numbers between 3 and 200. Now I wrote the same program on the TI-99 with a few small changes to accommodate the weird syntax of TI BASIC, but otherwise it works the same. Now let's run them and we'll see how it goes. The PET is clearly going faster despite the fact that the TI-99 has a 16-bit CPU running at 3 times the clock speed. Now, we'll skip forward a bit, but the result is clear. The PET was able to run the calculations 3 times as fast as the TI-99. However, the weirdness doesn't end there. So let's have a look at a typical game cartridge. Inside, you'll see this one small chip. It doesn't appear large enough to be a typical ROM chip. In fact, this is known as a GROM or a GROM. And there's space for up to 5 of these chips. Now, these chips are really more like storage devices than ROM. The closest analogy would be a modern SD card. Basically, if you look at the pinout, you'll see on one side you have rather typical stuff like ground and power, but on the other you have these 8 pins, which actually double as both address and data lines. You have to write to the chip to tell it what byte of data you wish to receive back. The CPU can't execute code directly from these GROMs. However, the GPL interpreter can. So generally any code on these chips will be written in GPL. The chips can store only 1800 bytes apiece, and if you had 5 of them, that would be a max of just a bit over 8K of code. So really not a lot. And this goes a long way to explain why most of the games of the system are slow and rather primitive in terms of graphics and sound. However, let's take a look at another cartridge, such as the mini memory. You'll see there's a lot more going on in this thing. It's not just a RAM expander, it has 4K of ROM, 4K of RAM, and 6K of GROM. So a little bit of everything. And it has a battery so you can store your own programs on it, but as you can see, cartridges can use traditional ROM and RAM if needed, which would allow direct CPU access. This was actually a pretty neat cartridge though. It had an onboard assembler and you could write code and take it over to your friend's house even without needing a cassette or disk drive. Okay, let's change gears and talk about the graphics capability. The heart of this was the TMS-9918 video chip, also referred to as the VDP or Video Display Processor. The text mode of this chip is 40 columns by 24 rows, which was fairly standard for the era. However, in this mode, you have characters that are 6 by 8 pixels in size, and the screen is essentially monochrome, with only a global foreground and background color selectable. What's really interesting about this mode is it was almost never used. When you boot to BASIC on the TI-99, it's actually using a 32 column mode, and in practice, BASIC programs can only use about 30 of those columns. We'll come back to this mode in a moment. It's possible to see the 40 column mode being used in some software, such as this text editor program, but it was also used in some terminal programs as well. So believe it or not, what BASIC uses on the TI-99 is actually what is referred to as graphics mode. In this mode, you get 32 by 24 character cells, and each one is a proper 8 by 8 grid. Only in this mode, you can also define foreground and background of each character cell, and you can pick between 15 different colors. And you can see these cells clearly in the demonstration program, for example. And best of all, it supports 32 hardware sprites. These can be either 8 by 8 in size or 16 by 16 in size, but they are monochrome and can be any of the 15 colors available, and you can stack sprites to add more color to them if needed. The vast majority of games operate in this mode using a combination of characters and sprites. When this came to market in 1979, it really did have best-in-class color graphics capabilities. Now, let's talk about the audio chip. It used the SN76489, which was a 4-voice sound generator. The first 3 voices could produce square waves, and the 4th voice was a noise channel for sound effects. This chip was actually quite capable, and when it came to market, it was better than any sound generator found in any other computer. In fact, this same chip, or clones of it, found its way into dozens of other computers, far more than I can list here. But some notable examples were the BBC Micro, the Coleco Atom, the ColecoVision, IBM PC Junior, Sega Master System, and the Tandy 1000, just to name a few. And here's an example of how it sounded in TI's 1979 demonstration program. So what sort of expansion options did the computer have? Well, as you already guessed, it could use a cassette recorder for programs, which was common at the time. But what if you wanted some actual memory on the system? Well, there was this 32K memory expansion device here. Where does it go? It goes in that side expansion I showed you earlier. And guess what? It needs its own power supply too. But what if you wanted to connect a modem? Well, first you'd need another expansion to give RS-232 ports like this one. And can you guess where it connects? Yep, it connects right here. And it also has its own power cord as well. And once you have that, you could add a modem, such as this acoustic coupler here, which also has its own power supply. But we're not done yet. What if you wanted to add a floppy disk drive? Well, great news. There's also this disk controller expansion too, and guess where it goes? Yep, right there. Oh, and it has its own power cord as well. And then we could put the disk drive on top of that if we wanted, and it has its own power cord as well. But what about a printer? Well, TI made this cute little receipt printer, and guess where that goes? Yep, right here. Oh, it also has its own power cord too. And TI made this neat little speech synthesizer, which basically uses the same speech chip as the Speak and Spell, and it can plug in, you guessed it, right here. So this is what a fully expanded TI-99 system looked like, and you'd need a whole power strip because there would be 9 power cords to power all of this stuff. And also, interestingly enough, each device has its own power switch too. TI did have one thing going for it, and that was the price. Initially it cost $1,150, and that included the color monitor we talked about earlier. That wasn't bad at all for 1979. The trouble was, within months of coming to market, it had to compete with new computers from Atari, Radio Shack, Commodore, and IBM, and this led to the introduction of an improved and cheaper model, the TI-99 4A. This will be the computer most people will be familiar with when thinking about the TI-99 series. The 4A model came out in June of 1981. I happen to have a boxed version here, so let's see what's inside. Unfortunately, this isn't packed exactly how it would have been from the factory, but there's still some interesting things in here. Here's a basic reference card, and this is an offer for some sort of online service, which does require a modem, of course. And here's some sort of pamphlet for the Computer Advantage Club. And we get some of these. These are meant to label keys on your keyboard. Since we don't have the chiclet keyboard anymore, these can slide on this little section right here and be changed out for each application. Next, you get a quick start guide to tell you how to connect everything up. Then you get a user reference guide telling you just about everything you would want to know about the computer and its operation. Overall, the documentation with the TI-99 4A is quite good. Let's take a closer look at the 4A. Externally, the main difference you'll notice is, of course, the better keyboard. There were actually 6 or 7 different keyboard suppliers used by TI, so one model can have a very different feel to another. Mine has a mechanical keyboard of some kind and feels pretty good. One of the differences you may notice is the lack of a headphone jack here. However, there are some internal differences as well. One is immediately obvious when you power the machine on, which is they got rid of the built-in equation calculator. The other improvement has to do with the VDP. It was upgraded to the TMS9918A. Now, this version of the chip is backwards compatible with the previous in every way, but also offers one extra feature. It includes a bitmap graphics mode. This mode is really similar to the regular character graphic mode. The main difference is that in regular character mode, there are technically 768 cells on the screen, but only 256 characters available, which means you can't technically paint the entire screen with custom graphics. So this mode allows 2 additional character sets, which means you can have 768 unique characters on the screen at the same time, allowing the entire screen to be filled with custom graphics. Now, this particular version of the chip was also used in other computers, more than I can name here, but a few notable examples are the Coleco Atom and ColecoVision home console, the Tomy Tutor, Naboo Network, Memotech, and Sega SG-1000 game console. Another improvement was the new Extended BASIC cartridge. Now, this added much needed enhancements to TI's BASIC. Now, for one thing, it was written directly in assembly language instead of GPL, thus eliminating that extra layer of translation, so it runs faster. In fact, let's perform a test using the same prime number code we used earlier. It now completes in 1 minute and 43 seconds rather than 2 minutes and 47 seconds, shaving almost a minute off the result. Unfortunately, it's still slower than the Commodore PET version. The new BASIC also allowed using expansion RAM if you had it, rather than video RAM, and also included many new features with the language itself. TI also had some television commercials starring Bill Cosby, a very popular actor at the time.
Computer, this is the one. Texas Instruments home computer. With
Other commercials tried to emphasize the educational value of the computer, and despite having a fairly large software library at the time, the software may have actually been at least part of the reason for the computer's ultimate failure in the marketplace. Moby Games shows 239 titles for the TI-99 series. The problem was there was a lack of good software. There are some notably good games on the system from companies like Atari or Activision, but in the early days, TI limited who they would give the documentation and developer tools to. And the other problem was games were expected to be mostly on cartridges, often using the GROM, so there just wasn't a lot of space on these for complex games or detailed graphics and music. The second problem TI had was the Atari 400 and Commodore VIC-20, and to some degree Radio Shack's color computer. They were just so much cheaper and more ubiquitous, and when the Commodore 64 launched in 1982, that was basically the death knell for Texas Instruments. However, they made one last-ditch effort to compete by launching a cost-reduced version of the computer in 1983. I happen to have a box version of one of these as well. This one is made of beige plastic and more closely resembles other computers from the mid-1980s. It comes with a lot of the same stuff in the box as the previous generation. Overall, the machine is laid out exactly like the previous versions. It has more or less the same dimensions and is totally compatible. The only real difference is the location of the power switch being moved up to this location. The cartridges may not be the right color, but they fit and work just fine. Likewise, peripherals meant for the previous two computers will also fit and work on this one. Now, I've seen reports that TI had the price of this model down to just $100 and still couldn't compete with Commodore. And so in March of 1984, TI threw in the towel and discontinued the TI-99 series. However, the computer lived on in a way through other machines. The Tomy Tutor is an interesting example. This machine is basically a TI-99 in disguise. Although not 100% compatible, it's basically the same computer inside. But when you look at the various computers and game consoles that use the same video and audio chips designed by Texas Instruments, you realize that parts of the computer lived on for many years after. Even the Sega Genesis, which was produced well into the late 1990s, was still using the sound chip from the TI-99. So there's some food for thought. And of course, we need to talk about some of these homebrew games. In recent years, TI has seen some new games like Titanium, Flappy Bird, Realms of Antiquity, Flying Shark, Bouncy, and of course, Dragon's Lair. Of course, I expect people to ask about my game, Attack of the Petsky Robots. It currently works on 25 different platforms, but the TI-99 is not one of them.
So over the years, many people have looked into making a port for the TI-99. And I'm not saying it's impossible, but it is certainly not easy. There are a lot of challenges to overcome that wouldn't be present on other computers. That being said, I think it could be done if you required the user to have at least the 32K RAM upgrade and then also a disk drive. And I think the problem with that is it narrows the audience of potential players down to like a few dozen people. It's really not worth the effort for that. Now, the other way it might be done is, of course, make it a cartridge game, but it couldn't be just any cartridge game. It would need to include extra RAM, ROM chips, and probably some GROMs too. So it'd be a fairly complex cartridge, but that could be done. So in theory, yeah, it's possible. And then maybe a couple hundred people might actually end up playing it. But who knows? Maybe someday someone will write it.
But wait, there's more. One big peripheral I didn't show was a peripheral expansion box, or PEB. I don't own one of these, but I know somebody who does. David Lovett brought over his PEB so we could demonstrate it.
So to open it up, there's these two like little clasps right here that you got to push in. And they're a little sticky. There's one. There's the other. And then the whole top comes right off. And then the good thing about the PEB is that it's all in these like nice little cartridges that just pop right out. So this is a 32K memory expansion as opposed to like the big chunky box that has its own separate power supply. It's just all in this single card and you have one big chonker of a power supply that services everything. So there's 8 expansion slots, and I think the standard PEB only ever came with the disk controller, the RS-232 expansion, and the 32K memory expansion. But there's a couple more cards that you could get. I think there was a P-code card for it and a video controller card, and there might be like 1 or 2 more that I'm not remembering right now, but this is pretty much the standard layout. And so you've got this nice compact peripheral expansion box, but then you have to plug it in with this monstrosity. Like, I have no idea. It's so silly. But it plugs into the side just like an expansion card. It has a little foot to keep it elevated off the table. And then that should be all that you need to do if you're ready to do TI stuff. So to run multiplan here, you need the disk controller because you have a disk for it. You need the 32K memory expansion, and you also have to put a cartridge in. So multiplan, Microsoft Multiplan here is like super boring Excel type software, but it uses pretty much every facet of the TI-99. So now that we've got the cartridge and the disk in, we can go to 2 for multiplan. It's going to say install program disk, press enter key to load. The program disk is already in. I'll hit the enter key. The disk controller cartridge or thing was in this slot, so we can see it's illuminating for that. The disk is being hit, and then the 32K memory expansion was in, I think, slot 3 here. So yeah, whenever it's putting something into extended memory, you can see it illuminate that light to know that it's using that extended memory. And here we go. We've loaded up the most boring piece of software you'll see in your entire life, a spreadsheet.
And I hope you learned something interesting about the TI-99 home computer. But that's it for this episode. As always, thanks for watching.